Uh, Good evening, my dear kids. In today's class, in the chapter Laws of Motion, we are going to study the application of that Newton's second law, like inertia of rest, inertia of motion. Means suddenly on a system, if a force acts, if the body is in the state of rest, it will now acquire inertia of motion. Or sometimes if the net force is zero, if the body is having state of rest, it's going to continue its state of rest. So these things is what we are going to analyze in this particular numerical. You can read this question. Find the acceleration of block just after string is cut. It is in equilibrium initially. So you have a one thread and the other one there is a spring. Let's keep one diagram. So initially this in equilibrium. So what are the forces? Tension, 2 mg. Start like this the problem. There's a tension will act here. Then here the weight will act mg. Okay, this here spring force. Kx you write it. Let's write that forces acting, then we'll see after cutting, then what will happen to the system. This is one method, almost all some 10-15 problems are there in books, all the ideas are same like this. Block B is at equilibrium. T minus 2 mg equals 0. So tension equal to 2 mg. Then on the block A, Kx minus T minus mg 0. So what is the tension? 2 mg and this is mg. So Kx equal to 3 mg. I think these are the things which I'm going to take help. Now, the string was taut, no? So you write it. Nearby string, it was a taut. When I cut it, that is when I cut it, so what is the state of the string? String it will be loose. So here you show like this, nothing wrong. Huh? So you will have an exact picture. Now what is the tension the string? It has become 0, no? Then what is the only force acting on the block? It will be 2 mg. So what is the acceleration of the block B? That should be equal to force 2 mg by mg. It will be downward. Agreed? Let's come for the block. The tension suddenly vanished. Sir, what happened? Tension got vanished. Are you looking here? The string I'm showing you. It's a loose, no? So no tension will be there here. Then what are the forces acting on the block? M, weight mg, and now anything will happen to spring force. Spring force will change only when its elongation, when it get deflected. The spring force will change only when it's get selected deflected. So just after the moment you cut string, then only I'm asking you. So the block A will definitely will be so what is the thing, that one will not undergo displacement, so therefore there won't be change in spring force. So the spring force, how much is there, that much only will act here. Now earlier the spring force was balancing the mg and tension. Now the tension will vanish. So definitely earlier Kx was mg plus T. Now the tension vanished here. So net force on the block A will be upward. what is the acceleration of block A? Will be kx minus mg by m. Kx was equal to how much? 3mg by mg by m. 3g minus g, this will be 2g. This will be upward. So now, what is the idea? Earlier they were at inertia of rest, no? Suddenly the net force, net action force on the block B non-zero. So from inertia of rest, it will change to inertia of motion. Similarly, block A, it was having inertia of rest. Suddenly when you cut this string, the net force will become non-zero. From inertia of rest, it will become to inertia of motion. The net
Sir,
force non-zero, it will move.
where is the string cut, sir? At which part it's cuts?
Here, no. Cut. I cut it here.
Okay, sir.
Okay, I'm showing the string here, no? It will be, huh? So it will
Okay, sir. Understood.
net force non-zero, so it will accelerate. You don't get anything, no constant equation, nothing is there. Huh? Just only that inertia of rest, inertia of motion. Net force zero, net force non-zero. There's a first basic problem. We are starting from here. Huh? The arrow indicates upward, downward. I need not to write sentence. Just let me indicate in by that way. Upward and downward.
Sir, will the spring have any tension?
Sir, 1 minute, can you scroll, sir? 1 minute, sir. Thank you, sir.
Sir, will the spring have tension?
Spring will be, spring force will act, no? It has to be there. What will happen to spring? Nothing.
Along with spring force, tension will not be there.
What do you mean by tension? Yeah, this string is cut, no tension.
In the spring, sir.
In the spring force is acting. Why you are calling in the spring tension? In the spring force will act. We have
Okay, sir.
discussed, no? Yeah. No. The block is in equilibrium, so here the weight G will act. Find the acceleration of block just after string is cut. So what is needed for us? Now it is in equilibrium. So what are all various forces acting? First get them. Now there will be some tension, the weight mg will act. Spring force kx, tension the string will be taut, let be tension. How to calculate the spring force? So first we'll go for kx cos 53 minus mg equal to 0. So value of kx will get it. So this will be 5 mg by 3. Kx value is 5 mg by 3. Keep it in hand. Now we are going to cut the string. No longer the tension, the string itself is cut, the string will become some sort of, no tension will be there. But anything will happen to spring force. Spring force will not change. What do we expect now? Under action of these forces, we have to check it. How the block at that instant only. The question is asked at that instant. Get into calculation part. Okay, here along y-axis, let's assume that one ay, the acceleration of the block, ay and ax. Is there any force acting along x-axis? A spring force. So kx sine 53 equal to max. Kx equal to how much? 5 mg by 3. Sine 53. Acceleration is 4g by 3. Let me check it. Anybody? Value sine 53?
4 by 5, sir.
4 by 5, sir.
4 by 5. So this will become 4g by 5. It will be directed toward. What about acceleration along y-axis? MAY.
Sir, 4G by 3, sir.
4g
Yes,
by
sir.
3. Okay.
Yes, sir.
Yeah. Thank you. Mg minus kx cos. We know kx cos 53 equal to mg, no? So therefore, is that okay? Means like, sir, like along y-axis, it will not have acceleration because net force on the block along y-axis is 0. Along x-axis non-zero, it will have acceleration along x-axis. Just F equal to ma. Here we are taking the in the direction in which net force non-zero, in that direction it will accelerate. The direction in which net force is 0, in that direction there won't be acceleration. Of all, this is very important. Initially, what is the tension, spring force, all the equilibrium, how it is in equilibrium. First, we should have background. After cutting string, then we'll see. Sir, why spring force will not change? Spring force will change only when the block undergo displacement. No, and what is our question? Just after, I think able to understand. 9 a.m. will start the class. Just after starting class means what does it mean? 9 a.m. only. 0. You can add some 0.9.00000 seconds. Just t greater than 0. At t just 9 a.m. I started. Just after 9 a.m. started means almost at 9 a.m. only it is. Able to understand this one? So the spring will undergo deformation only when the ends of the spring undergo displacement. The moment I cut the string, what happens? The ends of the spring will not undergo displacement. So therefore no change in spring force. As it is, I'm showing it. Sir, only at one end you are showing. Okay, I'll show at other end also. Okay. I'll scroll down, make observation. Slowly we'll take the pulley in the connecting system. Yeah. Here it is. Here there's a point P. Later we'll bring a problem. First we'll analyze, work out one by one. We'll cut this string, we'll cut this spring. Well, whatever we want, let's cut later. Slowly we'll develop the ideas. Now the system is in equilibrium. Okay, let's keep the question for our reference. Then first we'll show the system which is in equilibrium. at equilibrium. First we'll start with this one, m1g, spring force kx, here kx, m2g, here some tension T, here tension T, here some tension T naught, no problem, let it be there. So why you are putting different tension? Definitely this tension should balance the weight plus this tension, no? So definitely these two should be different tensions. This will be really very now what I'm going to do, I'm going to cut this part. This string is what I'm going to cut. When you cut it, how it will be?
Worked out.
Yeah, we have this one. Now you see. Start analyzing. The weight will act. What are the conditions, let it be there in the problem, the weight of the blocks will act due to gravity. Fine, this is there. Then
Sir, there at M2, above M2, why the string will become loose, sir?
if you cut this rope, this everything will become loose. No, there's a one common string. Why this will become loose means this everything is one common string. No.
Yes, sir.
Okay. Now let's get into this one. What will happen to this is loose. There's no tension here. Finish or leave it. Now let's come for this one. Block M2. Just after cutting string, there's no displacement of M2 and M1. So no change in spring force. So let's be as it is. Now net force on the block M2 you see downward. On the block M1 we'll put it in this way. Now we'll check first the block M2. Earlier there was net force 0. Now the net force is non-zero. From it was at rest, now it starts moving. So let's write the equation now. M2A2 equal to M2G plus Kx. Kx equal to, okay, from here I'll bring it. Kx equal to earlier tension something, let it be. And this T naught, okay, can we write T naught? So what is T? T minus all these equations will write. Now tension equal to M2 plus M1 into G. The other T plus M3G, or say T minus M3G minus T naught equals 0. So T we know. Okay, the initial, these are all the tensions. Now what is Kx? Kx equal to M1G. What is the direction? Upward or downward? Should be downward. So the block M2 will start moving down. What about M1? Let's see it. M1A1 equal to M1G minus Kx. And Kx equal to in fact M1G. So block 1 will be attached, block 2 will be in motion. So block M1 shall I put like this? It will retain its inertia of rest. This is the main purpose. Why we are studying is just to conclude that laws of motion very systematically. Net force was zero. It was why it is at rest? Because net force is zero, inertia of pressure. Why again after cutting string? Why it will not move? Net force zero, so it will continue to be its state of rest. It will continue state of inertia of rest. Why this will start moving? Net force non-zero, it will start moving. Block M1 will be attached. What about M2? Block M2. What about M3? Shall we show any tension that blue color string? I want from students this one.
G and
Shall I write T naught?
zeros.
No, it's because the tension is set up by what?
By
Pull
pulling
forces. Pull forces, not push forces. The here what happen when you cut this as weight M3G will act here. The M3G here what happen will try to push this. Pull forces will set up the tension, not the push forces. M3G is acting. Definitely this ground is there. So therefore here some sort of push forces is set up. This string now after cutting what we have to show? We have to show it
Zero.
like this.
Tension zero.
So that it will be loose. It is not cut but it will be loose. Because the push forces cannot set up the tension in the string. So therefore MA3
G.
will be downward. So these are the accelerations of the block. Okay, we are going to discuss problems of these kind. I think we have to be a little bit alert. We don't have any big equations here.
Sir, in the third line, M2 should be transferred, no, sir?
M2?
M2 should be transferred from left side to right side, no, sir? You wrote M2 plus M1 by M1, sir.
Where you are asking?
So, right side, third line, sir. Yes, yes.
Oh, this is M2, no? Yeah. So M2 I should send it to denominator, so this will become
M1 upon M2, sir.
1 plus M1 upon M2. Okay, yeah. Yeah, thank you. These are just some conclusions. So block M3 will move down.
Sir, block M2 will exert force on the spring, then also the spring force will not
Block M2 will exert force.
on the spring.
Its weight is acting, spring force is acting. What is the thing exerting again?
It is coming with M2
Nothing. Don't think like this all. Block M3 will move down.
Okay.
New things don't introduce at least. Hope everyone is getting slowly the idea. You have to just make observation. String is loose, tension zero. If a string is cut, the tension that will vanish. Then inertia of motion, inertia of rest. So will it continue to be in state of rest or state of motion? Net force non-zero, from rest it will get into motion. If net force is zero, it will continue to be in state of rest. These are the ideas is what we are talking.
Also, sir.
Yeah, we can cut spring also. What is there?
Sir, here T naught will be greater than T or T will be greater than T naught.
Check it, ma, here. T should be greater than T naught, no? Mathematics, check it.
Okay. Sir.
Read the question. Now carry on. Now you know some idea, no? Just try to apply the things. First, you get the equilibrium. At equilibrium, what are the forces acting? Then, what is being cut in the system? After something is cut, string or spring, then what will happen? Looking at the diagram, we have to write equation, then we have to conclude. The weight mg, tension T mg. Here, what spring force will act? What you call tension? No, this is nothing but string connected like this to the spring. So that the spring force only you have to show it. Kx, call kx. This is kx, and this will be the spring force. And the spring will be elongated. If the spring is elongated, how the spring force will act? Should act away from it. If you are getting confusion with so many, just you can show only the spring force once. Spring is elongated, no doubt.
Sir, where we are cutting the string, sir?
Here. String anywhere you cut it, here.
Up, sir, then up block also string only, no, sir.
This is called like a
Up
string.
is spring.
This is called a string. This is everything is like a spring. Okay.
Sir,
Okay, sir.
above
Okay, sir,
wood
understood.
block, it is a part of spring only, no, sir.
Part of a spring only. Yeah. Now we are going to cut. Okay, this diagram will not work. Now this we will remove it. Show the forces acting now. As usual, is mg. Now, anything will happen to the spring force?
No, sir.
Spring will, as usual, there's no deformation of it, so spring force will not change. So this block will have acceleration upward. This will have acceleration downward. We'll assume like this. This is a block A and B. Now acceleration of block A, ma is equal to kx minus mg. Kx equal to, how much kx must be equal to? T minus mg equal to 0. For block B, kx minus t minus mg equals 0. So kx minus mg equals 0. This is initially at equilibrium. So let's write 2mg minus mg. What is the direction? Upward. For the block B, mab equal to mg. Downward.
Like they'll have a free fall, sir.
They will have no, B will have free fall.
Oh, yes, sir. Yes, sir. Got it, sir. A will go up.
Okay.
Yes, sir.
Sir,
Hmm.
sir, kx minus t minus g is, you have applied that equation for block B as sir.
Yeah, block A.
Block B.
Block B, t minus mg equals 0.
Okay, sir.
Not that easy. I think we have to be extra alert. It's not that they are tough. We have to be extra alert. Really very challenging, but students really they have to they're going to learn a lot these problems. No concept, nothing is there, just the laws of motion, how well is able to apply crystal clearly.
Sir, both the blocks will have same acceleration, sir, in opposite direction.
Yeah, it's there. No, g upward, g downward.
Yes.
Here I'm going to cut all the things, huh? One by one we'll cut all the things. Or we have one more, we'll see. I'll come to this. First we'll see this one. Last in the end we'll go for analysis. Carry on this one. Some concept we are going to generate here that will help us.
Left side fully to spring, sir.
Yeah.
Sir, even the string which is above B mass, the block B will.
All the black is spring on sir.
This you treat, let it this be a string, my dear. But
Okay,
this
sir.
is connected to springs. Here the color I shown, please understand. Huh?
Yes, sir. Spring force is acting on.
How come yeah, how come this is one spring, this is string. These all three are different. That's why you should play kite. What is the reason why we ask you to play? No, this is very important. If you don't play things, very difficult, not possible to become engineer. Playing things with different objects is very essential in childhood.
We'll experience tension.
Then all the things are there. No? When you don't play anything, directly come and want to become engineer, how it is possible? I don't know what so many stupid schools, colleges are there where they're against playing. How it is possible? Huh?
Yeah, I do play kites.
Okay, now let me draw the pose diagrams. In your notebook, don't draw so many diagrams. You have to have a good explanation. I'm going for the diagrams here.
So your voice is
In
breaking.
the existing one diagram only, there only show it, and after cutting, you go for two diagrams. I think okay, fine. Now first, we'll start.
Sir, your voice is breaking, sir.
Let me continue. Okay, now at equilibrium, let me go for it. 3 mg. Here, spring will be elongated. Kx. This is kx. Show it here. So this is a kx. Kx minus 3 mg 0. So okay, that kx equal 3 mg. Then at this particular point, you look at this one. Mg will act. It will have some tension. Here tension T. Mg. Let some tension T naught. Let's find out what is the tension. Kx minus mg minus T equals 0. Kx equal to 3 mg. T naught has to be, okay, can we calculate the tension T naught? That also we can do it. T minus mg minus T naught equals 0. Okay, we got tension, spring force, everything. Okay, now I'm going to cut it. Everyone is B and C is something not analyzing properly. It's not wrong, not analyzing properly. So no question of this. Keep it here. The string is cut. Now. No, Pranay. Okay, now I'll explain. You make observation. 3 mg. Spring force. Now I'm going to say, okay, the spring force will not change. Why spring force will not change? Why the spring force will not change? Okay, when I cut this string, sudden change in spring force here not possible. You can see, but sir, like this is connected, this block C. See, first what will happen? The block C should accelerate. Due to acceleration from rest, it should get into inertia of motion. Then after some time, B and C will undergo displacement. Then this end of the spring will have displacement. But we are discussing just after. So therefore, there is no change in spring force. So the Kx will remain as it is. Here also I'll bring Kx. This is what happens. So definitely, what is the block A? 3m into acceleration of block A equal to Kx equal to 3 mg. So block A we are discussing problem just after only. Let's see here. The weight will act. The weight will continue to act. What will happen to the tension? This is very important. The tension is going to change some other value. T dash. Some other value. Sir, sudden change in tension possible. S. Sudden change in spring force? Not possible. So there's one golden statement is what I should add up somewhere here. Possible. Sudden very important. All these numericals just revolve around these ideas. Sudden spring force is possible when you cut spring. That's all. When you cut spring, yes, okay. Let's put some sort of statement. Huh? Now come for this one. So sudden change. Yes, there will be some change in tension. So why you are changing? Why don't you keep T only? No, earlier you see that one mg plus T naught were there. Now this T naught suddenly vanished. This tension has to change. So T dash will put it. Now Kx. Look at the spring force. How much Kx is there? This force should be. So let it accelerate up. Why you are putting same acceleration? Next, one more beautiful question here. They're connected by a common string. The accelerations must be equal. Block B and C, they're connected by a common string. The accelerations must be equal. So therefore now, so what we do is like Kx minus mg minus T dash equal to ma. T dash minus mg equal to ma. Masses are same. Let me add up these two. And let me add up these two. So it will be Kx minus 2 mg equal to 2 ma. Kx equal to 3 mg. What is the acceleration of the blocks? Many of you gave answers. Intentionally I was asking you to check it, means I wanted you to really think. If I say wrong no, you'll start analyzing still more beautifully. Intentionally some of you gave very good answers. G by 2. What is this? Acceleration of both the blocks. and it will be upward. What is the tension? Can we calculate tension? S T dash minus mg equal to me. Okay, look at now. Earlier, what was the tension? 2 mg. Now it will become 3 mg by 2. Slightly it will decrease because this pull force is decreased. No. Earlier T was balancing mg and T naught. So definitely when you take out this T naught, tension has to change. So therefore I am ending up with a decreasing value. B and C will have common acceleration because they are connected by a common string. I think this is very, very essential. Some of you give this answer. Four students give this answer, but intentionally I say it wrong so that you can go and think still more where we are going wrong everything. Now here afterwards in this such numericals, if the blocks, if they are connected by a string, if any one block moves, the other block should also move and they must have common acceleration. And this tension you cannot assume. It should be derived. Just let it be T dash and it has to be determined. You cannot directly take this value 2 mg, 5 mg, mg by 2. No, we don't know this. That has to be derived. Some spring cut we'll see. One problem we'll do at least spring when spring is cut. Oh, all the questions are thread burnt only. I'll bring one problem of spring cut. We'll take this one only. I don't have time. After string 1 is cut, I'll do one thing. First we'll cut the string 1, then I'll cut the spring 1. Remaining things you have to work out. String 2, spring 2, string 3. Okay, first two cases we'll discuss. String 1 is cut, then spring 1 is cut. The first case is what we have here. Read the question. Carefully analyze. Little bit so many blocks are there. No, first have a clarity at equilibrium. Show all the forces acting. Don't get scared, nothing is there. First we'll take the equilibrium. Yeah, sir, how to start the equilibrium one? So we will start with mass of the block is 3g. Here tension T3. If you better write directly 3g, you can save a lot of time. Mass of the block is 2g. Here 3g. Spring force will be 5g. To save time, I am writing like this. Mass of the block C is 1g. So how much of tension here? This will be 6g. Now you can, in exams, you can use this method also. Okay. Mass of the block B 4g. Mass of block A 2g. This will be 2g. I think justified. It is in equilibrium, you can see. The net force should be 0 because all the blocks are at rest. At equilibrium it is. This is one method I'm showing to save time in exam because you can't write so many equations solving. In the diagram only we should manage most of the things. Now we are going to cut the string 1. Just after string 1 is cut. This is the first case. String 1 and spring 1, we have less time. Spring 1 also, after this we'll do it. We are going to cut this string. We'll see what will happen. I have to just show string 1 is cut. I'll remove that name itself. No doubt this will fall. Let's see. Very carefully, so many things are there. First we'll start with the spring one. When you cut this, anything will happen here. The block B, will it move? Block B, will it move? Yes, no, earlier 6G was balancing 4G. It should move up. Spring force will change. No, spring force will not change. When spring force change, after block B starts, after some time, as the block B starts moving up, then the spring force will change. But we are discussing problem just after. So spring force will not change here. Agreed? This is very, 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 very important. So here 2G is there. So this 2G got vanished. Spring force will change. When spring force will change? When this block B starts moving. After it has undergone some displacement. But what is our question? Just after. Just after string 1 is cut. So the displacement of block B is 0, no? After certain time, the displacement will be non-zero, then spring force will change. So this will have acceleration AB upward. Then okay, yes, we have a string. It is connected to spring. So then this string is connected to this spring. So therefore, if the spring force doesn't change, the tension also will not change. So what is the reason? The string 2 is connected to spring 1. So there is no change in spring force. So no change in string tension the string 2. Let me write that expression. We are discussing first case, no? The tension in string 2 will be same as force in spring 1. So spring force in the spring 1 will not change. So the tension in the string 2 will not change. Therefore, tension in string 2 will not change. Okay, there's a one primary idea. Next after this, so acceleration of block B we are able to calculate.
Sir, means there will be no change in the system, sir. Tensions.
Wait, no. Why you want to conclude the problem? Let's analyze one by one. 6G, mass of the block B is how much? MB, will write it. MB equal to 6G minus 4G. MB is how much? 4G. This acceleration is upward. Okay, acceleration of block B, we got it. What about C? Acceleration of block C. So this block B moves, so block C will no. Block B is having acceleration. After some time it starts moving. So we are talking about just after it is cut. So C will be what happened? The spring, the tension will not change. The weight of the block C will be same as usual. 10 Newton will act. This spring force will not change. So what is the C? C will be at rest.
Yes, sir.
Force in the spring 2 will not change. spring 2, spring strings careful. So therefore what we can write, AC 0. Okay, now we don't have any problem. Now acceleration of block A got, block B got, block C got over. Now let's talk about D and E. Anybody wants to say about D and D?
It will be at rest. No, sir.
Rest
Will
on
be at
They will
rest.
be at rest only. No, sir.
They'll be at rest. So they will continue to be in inertia of rest, inertia of rest, inertia of rest, inertia of rest. Only this will have inertia of motion, inertia of motion. Only B and A will change the state. C, D, E continue to be its state of rest. This is what happens when string 1 is cut. Now spring will cut spring 1. All these are self-learning things. You can manage on your own. Make observation. We'll discuss the spring 1 is cut. What conditions will come. I'll scroll down.
Sir, when string 1 is cut, how it will be in equilibrium, sir?
Which
In
one?
third.
What? String 1 or spring 1?
String 1, sir.
Let me explain. Let me explain, please.
Okay.
Let me take this condition. Let's carefully analyze. We'll try. So what is our question? Just after spring 1 is cut, find the, okay, I'll put a boundary. Find the acceleration of blocks for the following situation. Here, find the acceleration of blocks.
Sir, now string 1 is not cut, sir. Only spring 1 is cut, or both are cut?
Only when agreed. Okay,
Yes, sir. Okay, sir.
spring 1, sorry. Make observation. No, put effort. Nothing. Don't get scared anything. Already we have some equilibrium. Okay, there's no problem. Okay, well, anything. What will happen to spring when you cut spring? What will happen? This is one primary question we have to ask ourselves. The spring force will vanish. So what is the idea now? What is the basic idea? I'll introduce that idea. When spring is cut, the spring force in it, this is ideal. Practically there are so many other complications are there. We are at a very beginning stage. Let's this is what it was advised for us. Vanishes means spring force will become 0. Quite easy. Then any string connected to spring, the tension in that also will become 0. So string 2 and spring 1, these are very important for us. So let me bring the diagram. I think with this problem you can manage, let the spring or string cut, you can manage. I think I had to show spring cut, no? Yeah. This for your let's show like this. No spring 1 is cut. spring force 1, that 6G will vanish. Now look at this. This string 2 is connected to spring, no? Here. This one.
Yes, sir.
So anything will happen to this tension, it will vanish because it's directly connected to the spring. So you do one thing, you may not agree this, just take the spring balance. For the spring balance, you tie a rope, and for the spring balance, you hang some mass. You cut the spring balance, the string will become loose. String 2 will not get cut, the tension in that will be 0. So here we'll give a reason.
Sir, tension in the string 2 vanishes in the sense what, sir?
Wait, no, let me explain. Please wait, have
Okay, sir.
patience. Huh? The string 2 is directly connected to spring 1. When spring 1 is cut, the spring force in 1 vanishes, and at that instant the tension in string 2 all will become 0. Though tension 0, it will remain straight. Sir, is it a tout? No, just straight. I'll remove this 6G. Okay, no tension. We'll write it here. Okay, fine. Okay, now block B, what will happen to block B? Here we have to be careful. What about tension here? 2G, we don't know. Call it some T1. This is the beauty of this problem. Now what will happen? Acceleration of block C should be downward, no? Why downward, anybody? Because 5G and its weight both are acting downward, so it must be like this. Then what about here tension? How much we don't know, so call this is T3.
Sir, sir, string 2 is extensible string, sir.
Strings are inextensible. Hollow laws of motion, that's what. No, string is inextensible, massless. Huh? Why new things you people are bringing?
No, sir, doubt I got, sir, because that acceleration, it will be downwards, no, sir.
String is inextensible, my dear. Take it for granted. Write in your notebook bold words. Huh?
Okay, sir.
Okay, now don't change the physical conditions. This is wrong. Okay, now we are here. So what we have to calculate is like the spring is cut. Okay, this one. What about acceleration of A and B? Will calculate first. So shall we work out this particular problem here? This will be 2G minus T1. They must have same acceleration. Any reason? They're connected by a common string. So 2G minus T1 equal to mass of the block A, 2A. Then 4G plus T1 equal to 4A. Let me add up this. 6G equal to 6A. So A equal to G. If A equal to G, substitute here. Then how much tension? T1 there. Like this we have to conclude. T1 I'm indicating tension the string 1 will be 0. But it will be, sir, like you are showing straight. Let it be. Now come for here. Acceleration of block C. What shall I write? This will be Mass of the block is how much? Mass of the block is 1 kg. MC into AC equal to
5G. 60.
mcg plus 5g. This is 1 AC. AC we have 6g. And what action? Downward. Okay. Okay, somehow we got it. Let's come for this one. What will happen here? Spring force suddenly will not change. When you cut this spring, this sudden change in spring force in spring 2 will not change. So that's we'll write it here.
AD and A will be 0, sir, then.
Yeah, that's what we have to prove. I'll prove that one.
Sir, then how T3 will come, sir, if spring force doesn't change?
Wait, let me explain. Spring force in spring 3 will not change. Spring force in spring 2 will not change. That already we know it. Okay, now what to do now here? So something T3 is there. Sir, you brought some other tension. Let's calculate. No, I'll assume that acceleration of this A dash. I don't know. Let's calculate. There'll be a test or in motion. Anybody? There'll be a test and tension string will not change. I will write the equation now. 3g minus T3 equal to 3a dash 2g plus 23 equal to 2a dash. You add up this 5g 5a dash. A dash equal to g. If a dash equal to g, substitute here. T3 is a dash equal to g. So how much T3 will come? One more. So okay, this one 2g plus T3 minus 5g here equal to 2a dash. Adding up this one 5g minus 5g. A dash is 0. If A dash is 0, substitute T3 will become 3g. Tension in the string will change, in the string 3 it will not change. Let's assume everything and conclude rather than it will happen like this. Getting the method? Look at your teacher, what he is doing. Sir, tension in the string, why it will remain constant. What I should explain is there's a better way, no? If I, instead of writing T3, if I say it will remain same, I think it's a blind guess, no? We have given a proper proof. So what is the acceleration now? AD equal to AE 0. So what is the thing? Any string connected to spring, if you cut the spring, any string connected to that spring, there the tension will vanish. This idea.
Sir, if a spring is next to another spring, sir, and that spring is cut, will there be any
work out? It's not a story, no. It's not like some Taj Mahal.
Yes,
where
sir.
if you ask me, I'll carry. We have to work out. Everything I should work out like this.
Sir, if a string is cut, it takes much time for spring force to change. But if a
Yeah, if a
spring
spring
is
is
cut,
cut, then tension the string will change.
okay, sir.
The string is directly, this string 2 is directly connected to spring, no? So any change here will be reflected here.
But if in middle any mass is there, then it will change.
Then if any mass is here, then this tension again you have to work out in this way.
Okay, sir.
That's why I suggest you take this problem, cut all one by one and work out. We have completed. I think you can try all these things. Huh? I think you have a class, will end up here. Huh? Okay, kids, like we had the application of, okay, now this spring 2 is cut. I have made everything adjustment here. Spring 2 is cut. Okay, the spring 2 is this one. No? This particular thing is being cut. You can see it here. The spring force in the 2 will vanish when spring 2 is cut. Spring force in it will vanish. Okay, we have this much here. So what about the tension here in this string? This is the very best question what we have to ask here. This string 2 is connected to spring 1. So therefore, if spring force here will change, what about B and A? Will they move? Nothing, no. They will remain as it is. So they will retain its rest.
Yes, sir.
Acceleration of B and A. Spring 2 is directly connected to spring. If any change here, the change will be reflected. So therefore, no change in the spring force. But sir, here some force changed. But this string is directly connected to spring. If if there is force in the spring 1 changes, then only the tension the string 2 will change. So it is directly connected. So this will not change. So this will not change. Okay, there is a one primary point. Next again, tension the string 2 as it is directly connected to spring 1. Because and what is the reason? The spring force here no change in and no change. If the force in the spring 1 changes, then tension will change. So here no change. So no, there is no change here, as it is directly connected to spring 1 and no change in okay. Now the block C definitely it should move up. We'll write it here. Sig G minus this is 1 it will be upward. The block C will move upward. Now what about the block D and D? Okay, let's work out. So but they must have same acceleration, no? So here 3g minus t is equal to MEA 3, I'll write it. And then t plus 2g is equal to 2a. Let me add up. 5g equal to 5a and downward. What about the tension in that? Put a equal to g. So what is the tension? Will be 0. Look at now how they'll have free fall. But the string what happened? Tension will be 0. tension the string 3 will be 0. Please look at. I think we should not say, what is the thing is, you should not assume on your own any value here. Are you getting? Don't assume any value on your own. Work out here. Look at your teacher, how what he did. Follow that method. So when you cut this spring, tension here changing. Here tension will not change because this string is connected to this spring. So don't conclude, don't generalize everything. Ah, sir, okay, thank you, sir. In all problems, I'll think. No, problem to problem, things are changing. Here this string is directly connected to spring. So if the here spring force will not change, tension will not change. Now if you cut this, why tension is changing? Because of the conditions here. Anybody having doubt, you can clarify. Anybody still having any doubts, you can clarify regarding this string spring cut. Okay, shall I end up the class?
Yes, sir.
Yes, sir.
Okay, then try to practice some problems based on these things.
Sir,
Yeah.
that material questions you allotted, no, sir.
Ah.
All are covered, no, sir, in that.
No, this spring strings cut, I didn't cover, no?
Yes, sir. That because I completed, sir, so I did not find those questions, sir.
You can try them, many are there, no? You can start
From
working.
Cengage book, can I try, sir?
Cengage or material, anything you can try, no problem.
Okay, sir.
Yeah.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Okay, thank you, kids, for your infinite patience after so much of technical things. No internet, still most of you are waiting to learn things. Really, very thankful for everyone for showing that much of interest in learning. Okay, thanks. Thank you, all of you. Take care. Bye. See you.
Thank you, sir.
Thank you, sir.